Let's do it.
Okay, number 6. You should write on your paper limit to start with. Okay, I've been asking a question in all my classes that I thought everyone would know the answer to, but it's been actually quite interesting that it is not an answer that comes to mind quickly for most people. It is a foundational idea. You'll hear me say over and over again, if you understand the big ideas, the little ideas are not that hard. But what happens is most of us fall into the habit of doing it the other way around. We are just so anxious to get our homework done that we just want the steps. And then we forget what the big idea is. So first big idea is they're giving you this green box. And when they give you that green box, they give you, to be fair, they are giving you an infinite amount of information. Like, no joke. Like, it is literally an infinite amount of information. What are they giving you? Hands up. Like, when they give you this, what are they giving? Hands, who knows? That's a pretty good question. I've noticed this is what happens. Like, not very many really are sure. Like, what is being given, Will?
Every point on the graph.
Nicely done. So they're giving you an infinite list. That list is an infinite number of XY pairs. And I like to think of it as the list first. Once I have the list, I can create the graph from the list. That's where the graph comes from. But it is literally an infinite list. If your hand was raised, give yourself 2, Will gets 3. Okay, questions? Okay, that's the first big idea. The second big idea is, when they say analyze the continuity, you should think of this number. 3. They're literally asking you to see if you can identify basically 3 different points. And that's all they care about. It's not technically 3, but that's a good comparison. So one of those points is x equal negative a. That is a definite point that you are supposed to identify. And then the other points are just those that are infinitesimally close to negative a. These are the points that aren't strictly a point, but it kind of helps to think of them as being points. And that's it. That's the big idea. You have the list of XY pairs. They want you to find 3 of them.
So you should, you need to find those points or most problems. But this problem could you technically just plug in negative a, and because the bottom would be 0, it's not continuous, and then you can just say that it's not continuous with this problem.
3 points. If you plug in negative a, let's get the whole room to catch up. What are you going to get? Like what am I?
Undefined.
Undefined. You weren't bothered by that. Okay, so Will's correct. Once I know the value of the function is undefined at x equal negative a, it's certainly not continuous. Absolutely. And if all they had asked for is, is it continuous or not, which sometimes they do ask, you'd be done. It's good enough. In this case, because they're asking you to analyze, they want you to go a little bit further. They want you to show kind of step by step how you know. So if you had started with this, hold on. Like you had said, let's go find f of negative a. And you did it in your head, which is fine. There's nothing that is needed to be shown. So far, so good. But they would want more if they're asking you to show some analysis. That's all. So now we've got to go do the limit. So I can find those other 2, essentially those other 2 y coordinates. So now we are not going to plug in x equal a. We're going to plug in negative a, close to x equal negative a. And it is critical that you understand what you really get. And here's something, I don't know if I've emphasized enough yet, so let's emphasize it. Raise your hand, please. Do not say it out loud. I got to see how well the whole room's doing. My goal is to get all of you to pass the AP test, not some of you. Right there. for that purple, that's a term, or you can think of it as a fact. I guess it's more of a factor on the bottom. That purple factor, if you substitute in place of x a value that is not negative a, but is close, so it's almost negative a, what are you going to get on the bottom? Ends up, what value are you going to get on the bottom? Like what number? If you get a number on the bottom, if you plug in something that is very close to a, sorry, negative a, but it isn't negative a, it's like a little more, a little less. Will, what do you get?
Close to 0.
Raise your hand if you completely agree. 2 points, 3 for Will. You get very close to 0 on the bottom. There's close to 0. Hands up, what do you get on the top? So when you plug in really close to x equal a, what does the numerator numerically become? When x is almost negative a, but x isn't negative a, it's just almost. And less of you this time. Too bad, dash. So something also close to 0. Is it exactly the same number, or is it a different number? And how do you know it's different?
It's square.
Yeah, the way we calculate the numerator is different than how we calculate the denominator. So the number will be different, but it would still be close to 0. Oh, let's write this in a different way. Hands up. Who was prepared to say roughly what Dash just said? 2, 3 for Dash. So this is different, close to 0. This is why people say this isn't math anymore.
Wait, when you say different close to 0, do you mean it's like approaching on the other side? Or what?
Oh, good comment. Not, it could be the other side. I don't really know. I just know that the numbers are different because when I calculated the bottom, I took very close to a, negative a. I added that to exactly a, which if I take an exactly negative a plus exactly a, I would have gotten exactly 0. But because I put in a number that wasn't quite, I get not quite 0. On the top, I take that close to negative a, I square that. So that changes the value somewhat. Added to a squared, it's close to 0 again, but it's going to be some number that's different. I don't know what numbers they are. I can't really calculate them, but I know that they are both close to 0, but they are different values. I don't know if that answered your question.
That does.
3 more. Okay, hands up. What's this going to? Trick question, actually. Trick question. What is that going to equal? I always say trick when I feel like I'm not trying to fool you, but sometimes when I ask the question, like, wait a minute, that's kind of weird. What's the answer supposed to be? And it's kind of a tricky question. What's that equal to? Hands. Hand is raised. Give yourself 2. Tommy.
Close to 1.
3 points. Not true, though, to be fair. What is this equal to? Let's go 10.
Is it
No, but 3 points. Let's go, Ben.
Is it just we don't know? Like we don't have enough information?
That's a better answer. Like undefined's kind of, but not really. It's like we don't have enough information because we don't know how different the close to 0 number on the top is from the close to 0 number on the bottom. 3 points.
Either close to 1 or close to
3 points, but not necessarily. Like here's an example. When I say close to 0, I could have thought, I don't know, maybe it's something like this. And then maybe the bottom's also close to 0. The key idea is we don't know because we didn't do anything to truly calculate it. Like, we don't really know exactly what we're plugging in. We're plugging a number that's almost negative a, but I don't know. This is actually 100. That's not very close to 1 at all. So you've got to go with what Ben said. Like, you need to memorize this for sure. Like, this happens all the time. You get close to 0, and then different close to 0. When you divide them, you don't know what you have. In fact, it's a big warning that if you stop now, you're going to get the question wrong. Like if you put down 1, it will be wrong for sure. If you put down 0, the answer will be wrong. If you put down undefined, the answer is wrong. You just don't know what you have. Question. Please.
I'm confused why on top it's a different close to 0, not just the same as the other one that's close to 0.
Let's think of A as a number, it might help. So let's think of A as just being 5. So on the bottom we plug in something like 5.1. We add that to negative 5.1 plus 5 would be about negative 0.1. On the top we plug in negative 5.1, then it gets squared. So now it's different. It's just, I'm not really proving it, I'm more just saying because the computations were not the identical computations, I have no assurance that I really have the same numbers.
Okay.
Better?
Yeah.
3 more. Anything else? Okay, cool. So look, huge warning. If you get this, don't stop. Like, you haven't done anything other than identify that you don't know what you have. And for our class, usually what it means is you forgot to factor. Amanda liked to put on her sign that if you forget to factor, you're going to fail. This is a strong indication that you forgot to factor. So we go back. Come back over here, and we say, got to find the limit still, so let's factor. So we have the limit, x approaching negative a. Anytime you have, so this numerator can be thought of as one term minus another term. Anytime you have a term subtract a term, they always factor. All you have to do is take the square root of the first term, which is x, minus the square root of the second term. That's the first factor. Then you multiply by what's called the conjugate. And then you divide by, I'm not going to factor the bottom because I'm looking for a matching factor and I've already found it. So, just rewriting that. Don't forget your equal.
Wait, isn't it supposed to be x minus a on the bottom?
No, it's x plus a. You're getting close to x equal negative a, but the bottom is x plus a. 2 points for checking. So now we have this. Question. Back over here, making a specific comparison here. So now, raise your hand, please. If you choose a value that is not negative a, but it's close, raise your hand, don't say it out loud. What will the green factor's value become? Hands up. That's better. Let's go. Simon Irwin.
Close to 0.
So the green becomes close to 0. 2 points if you knew that. Simon gets 3. And on the bottom, hands up. What does the blue factor's value become? Let's go, Lainey Johnson.
Close to 0. But is it a different close to 0?
That was my follow-up question. Is the close to 0 value at the top same or different to the close to 0 value on the bottom? Go ahead, Lainey.
Different.
Tell me why you say they're different.
Because the green was squared. We just factored it.
Oh, stay with me. In the factored version, the close to 0 of the top was definitely different than the close to 0 of the bottom. That was right here. Once we factor, we have the same formula, just written out in a different way.
So now they're the same.
Yeah, so this now is calculated exactly the same that this is. Does that make sense?
Yes.
How many knew that? 2 more, 3 for Lainey. So now we get close to 0 divided by close to 0. Same close to 0. Same close to 0. Ends up. What's that equal to? Ends. What's that one? That's what Charles wanted to ask.
Isn't like close to 1 or 1?
So in this case, because they are exactly the same, there's no difference whatsoever. This one is precisely and exactly and totally 1. How many new? 2 more, 3 for Charles. Questions? Okay, pause. Does anyone want to talk about the difference between these two? That's the key idea. Like understanding this versus this. Please.
So on the top one with the different close to 1, is that just because it's squared or?
Yeah, it's, now, to be fair, I suppose we could maybe come up with some example where they turned out to be the same. But in general, if we're calculating the values differently, so this numerator is computed in a different way than the denominator because of the squaring. Also because this one's subtracting and this one's adding.
Yeah.
That difference causes this to happen. We get values, we literally get numbers, but each number is infinitesimally close to 0, but they are different numbers. 3 more. This one, the computations were identical.
So they have to be the
So there's
equation.
no way to get it different. Impossible. Please, David.
Are you just like telling us that like every time we face one of these problems, we should look for a fraction that will equal 1?
Not every time, but it is common.
Okay.
Like it isn't every time, but it is common. And you gotta watch out for the every, because that's how they'll try to fool you. You kind of get locked into thinking that I need to find it, and then of course they invent one where you don't. But I am pointing out something that is regularly happening. I've seen students many, many times go to solve this limit. They forget to factor. They get this, and they go, oh, the answer is undefined. And it's wrong. And that's what I'm just trying to warn you against. 3 more. I don't know if that helped very much anyway.
That's it.
Okay, please, John. Tommy said.
No, it's okay. I'm just thinking of all the numbers I can think of, the top and bottom are all the same.
For this one here,
Yeah.
just do it on a calculator.
Could you find an example number to do with?
Let's try it. I don't know. Maybe I'm making an error. Seriously, perhaps I'm making a mistake. I don't think so, but let's just find out. So it's clear here. Clear here. On the top, we're going to put, we're going to pick, tell me which one, A and B over here. 2. So we're going to take x squared minus 4. Is that okay?
Yeah.
The calculator can't handle the A. So we'll say x squared minus 4. And then on the bottom, we're going to just take x plus 2. Good? Cool. And let's do our table here. Second, my screen is terrible resolution. I would say those are very different values. Those are big values of x, though. Let's get x close to 2. Second table set. So we're going to go x close to 2. We're going to go up by just a little bit, 0.01. Second table. I don't know if I'm doing that right. Those are very different. I'm not sure what you were doing,
Well, I
but
was just thinking like, because x is supposed to be equal to negative a.
but the key is it's not negative a. You're right. If x, yeah, no worries. That's a good comment. Hey, no. Look, 3 more for Tommy.
No, yeah,
Does that make sense?
Yeah.
Yeah, if x is negative a, then they will be exactly the same. And they'll both be exactly 0. It's only when we go away. Does that make sense?
Yeah.
Answer your question. That's good work. Yep. Cool. So, when x is close to negative a, this is 1. Not close, it's 1. Raise your hand, please. What's this going to be when x is close to negative a? Hands up. One of the keys to all this is like you just do it little by little. Don't try to do it all at
Is it the yellow or
once.
the green?
Sorry, that was terrible. this green right here. What will that equal when x is almost negative a? There we go. Let's go, Will Avanda.
Close to negative 2a.
And then you're multiplying that close to negative 2a by precisely 1. And what would the result be, Clark's answer, brother Will?
Just negative 2a.
Close to negative 2a, so the limit is exactly negative 2a. Which means this y, so if we're doing xy pairs here, we find out that at a value that's slightly negative of negative a, our y value is close to 2a, negative. At exactly negative a, our y value is undefined. And slightly more than negative a, our y value is once again very close to negative 2a. 3 points for Will. If you knew that, give yourself 2. Let's go. Andrew.
So if f of negative a was exactly negative 2a, then the function would be continuous.
3 points.
But it's not, so it has the removable discontinuity.
Correct. Back to what Will said. This being undefined, we know the function's not continuous. It's just a matter of identifying which type. Please, Adam.
You need to write down that table.
You do not. The table is just me trying to get you to make a connection. The better your brain connects to something, the better you'll remember. 3 more.
Plus.
Yeah, please.
Do we have to write down so it's a removable discontinuity and all that stuff?
Yeah, since they said analyze, I'm trying to prep you for the written portion of the test. And I've seen students lose all the points on a 2-point question, because lose both points on a 2-point question because they just forgot that you have to do limits. Like, they want something like that. Now, to be fair, Ben, you can be a little more compact if you want. You should say this, so the grader knows you're trying to find a limit. You don't need both of these. You can write one of them. I wrote both just for additional clarity. Hello. You have to have the value of the limit. You have to have the value of the limit. You don't have to say however. I do that all the time. You have to have this. You have to have this. You got to have the words that it's a removable discontinuity. So. Yeah, please.
I'm just confused where the negative 2 came from.
Right here. So let's go back to here, Michael. Give me a second. Were you okay that we were able to say that finding this limit is exactly the same as finding this limit? You okay there?
Yeah.
Okay. So now we are trying to analyze what happens when the x value is almost negative a. Are you comfortable when the x value is almost negative a? The yellow box will be precisely 1.
Yeah.
Awesome. So all that's left is to analyze this little factor here. So you're going to take away the x. In place of x, you're putting almost negative a. Like close, not quite. And then you're subtracting a. So answer this one, Michael. If it were exactly negative a minus exactly a, what would you get?
Negative a is like close to 0, right?
No, my bad, sorry. A is just some number, we don't even know like what it is. Like you could think of it as 5. Like if you had this, you're really close to seeing it, just stay with me. What would that be? Perfect, good with that. But that's the same thing as negative 2 times 5. You okay with that? Okay, that's what's happening here. You've got a negative a plus another negative a. You have 2 of them. So is that better?
Yeah. You just kind of like break it down.
Yeah.
Okay.
3 more. Cool, awesome. Stop the video.